In this lesson, we are going to learn about the quadratic formula, and the necessity of the quadratic formula came about in the previous video because in the last example of the previous lesson, we encountered a quadratic equation which we could not solve by factoring. And in the previous unit of quadratic expressions, we also saw expressions which cannot be factored over irrational numbers. So that idea is not entirely new. The question is, how do we overcome this problem? So if you can't solve a quadratic equation by factoring, what you can always do is apply the quadratic formula. Okay, so we have the quadratic formula which will enable us to solve every single quadratic equation we want. But in fact, the idea of the quadratic formula comes from the idea of solving a quadratic equation by completing the square. So let me show you what I mean. You can actually solve every single quadratic equation completing the square. So let's make up an example here. Let's say it's x squared plus 6x minus 3 equals 0. So I'm going to solve this quadratic equation by completing the square because if you look at the simple trinomial on the left hand side, I can't factor that. Okay, there are no two numbers that multiply to -3 and add to 6. So since I can't factor, I'm going to solve this by completing the square. So I'm going to add by 3 squared and subtract by 3 squared. Be careful when you square root, we're going to write plus or minus. It's plus or minus root 12. I'll explain that again after we do example 1. And then x equals minus 3 plus or minus root 12. So there you go. I was able to solve this quadratic equation by completing the square. So people looked at this and said, you know what? We know that we can always solve a quadratic equation by completing the square. So now we're going to take that idea and generate a more efficient method, because I don't want to complete the square every single time. So we're going to generate a little shortcut. In order for us to generate the shortcut, instead of using numbers, we're just going to stick with letters. ax squared plus bx plus c equals 0. All right, so I'm going to solve it by completing the square. So quite a few steps. And we actually saw a few of these steps when you first learn how to complete the square. Okay, I want to create my perfect square trinomial, but this fourth term has to gotta go. But be careful, you have to multiply by a when you take it out of the brackets, so you get minus b squared over 4a. And we're going to move these two terms to the right side, so it's b squared over 4a minus c. All right, we're almost there. As I'm going to simplify the right side a little, so I have a common denominator of 4a, so this would be 4a or minus 4ac over 4a and divide both sides by a. Almost there. Square root both sides, don't forget the plus minus. Well, wait a minute, the denominator is 4a squared, which is a perfect square. And there you have it, the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So what does the quadratic formula allow you to do? It allows you to bypass all these steps. If you have a quadratic equation given to you in the form of ax squared plus bx plus c equals 0, instead of doing all these steps, which is essentially completing the square and then rearranging the equation and isolating for x, you could just jump to the final step. Okay? That's what the quadratic formula allows you to do. But you have to understand that the quadratic formula comes from the fact that every quadratic equation can be solved by completing the square. So if you happen to forget the quadratic formula, what you can do is just do it the longer way. Solve the quadratic equation by completing the square. So don't worry if you forget. You have a backup plan. But saying that, what you should always first try to do is solve it by factoring. If the quadratic equation can be solved by factoring, definitely do so, because as you'll see later on, you can save yourself a lot of time. Okay, so let's make use of the quadratic formula. I'm going to pretend like I forgot the quadratic formula. So I'm going to solve this first by completing the square, and I'll solve it again by using the quadratic formula. So x squared minus 4x minus 9 equals 0. So like I said, let's solve it by completing the square. Create that perfect square trinomial. Alright, so I completed the square, and now I'm going to rearrange and isolate for x. So square root both sides. So if you're still having a hard time understanding why do we write plus or minus, so let's look at a very basic example. So if someone said to me z squared is equal to 4, and your job is to solve for z, the very first thing you would say is that z is equal to 2, which makes perfect sense because that solves the equation. 2 squared is 4. But you have to be very careful because yes, 2 squared is 4, but you can also square negative 2 to get 4, right? 2 squared is 4, but negative 2 is also a root because negative 2 all squared is 4. So you have to remind yourself that when you square root, you cannot forget the negative root. Okay, it's very tempting to forget the negative root, but there are two roots that you generate when you square root both sides. All right, so now let's just finish isolating for x. X is equal to 2 plus or minus root 13. So I would solve this quadratic equation by completing the square if I happen to forget the quadratic formula. Okay. Now, if I do remember the quadratic formula, then I'm going to use a quadratic formula. So let's just start by labeling what a, b, and c is. A is 1, b is negative 4, c is equal to negative 9. And by the way, I only resorted to these techniques because I can't solve this quadratic equation by factoring. Okay, so let's just write down the formula. negative b plus or minus square root of b squared minus 4ac all over 2a. And after a few times, I think you'll be able to memorize the formula. So negative 4 is b. Well, that might make you feel very uncomfortable because now you're thinking the quadratic formula gave me a different answer than what you did when you solved it by completing a square. Now I know these values look different, but they're actually exactly the same. So in grade 11, you're going to learn how to simplify radicals. In grade 10, we don't do that. But I can show a link to the video where I show you how to simplify radicals. So I will convince you using my calculator. So let's say like 2 plus root 13, 5.6, let's say. So how about 4 plus root 52 over 2? Hey, what do you know? 5.6. So I promise you they are equivalent. Yeah, they just look different, but they're truly the same. So I want you to compare and contrast which way was faster. Was completing the square faster or the quadratic formula? I would argue that the quadratic formula is a touch faster, and I would say they're less likely for careless mistakes to take place when a student uses a quadratic formula. But you know what? There's nothing wrong with solving by completing the square. Okay, so always set it equals 0, right? Because otherwise you can't use a quadratic formula. Okay, so x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'm only writing the formula then because this is, I really wanted to sink into your head, so have it memorized. So plus or minus the square root is negative 4 squared minus 4ac all over 2a. Okay, so it's 4 plus or minus, this is 16, this is 8 times 9, 72. 72 plus 16, let me just triple check, yep. Bam, 88. You can simplify this. Some calculators actually allow you to, like, they simplify it for you and they give you a prettier answer. It's like reducing a fraction. Some calculators will reduce it for you, but since we don't learn this scaling, you learn this in grade 11. You learn how to simplify in grade 11, so I'm okay. I'm very accepting of this solution. All right, let's do another one. All right, x squared. Let's write it down a few more times. Hopefully you can memorize it by the end of this lesson. And if you want, you can write what a, b, and c is. So 4 times 3 is 12. 12 times 7 is 84. 84. Ooh, I just noticed something. 1 minus 84, negative 83. Okay, so we're going to talk about this in the next lesson as well. But these are the roots, okay? Now, in high school math, we see the square root of a negative value, and we basically say that the solutions the solutions for this equation are not real numbers, okay? Now they are numbers, they're just not real numbers, and we don't work with these types of numbers in high school math, but in university you may encounter them, okay? So if you see them, you basically say these are the roots, but they are not they're not real roots, okay? They're not real numbers. Now, if they explicitly say, like, solve for exact roots, where, let's say, if they add this little statement here, x is a real number, then you say no real roots, or no real roots would be a perfect thing to say. Okay, now since this wasn't there, you know what? I'm just gonna leave it like that. Okay, there's nothing wrong with those roots, but they're just not real numbers. Now, if you get a word problem and you get these kind of roots, then you say, you know what, just reject them. They're not meaningful with respect to the word problem that you're trying to work with. Okay. All right. Set this equal to 0, and then you bust out the quadratic formula. Oops, negative 1. So I'm just gonna push it right in. 4AC. 4 times 12 is 48, 48 plus 49. Ooh. So this is why I say what I said earlier. So once I saw 49, I saw that here under the b squared minus 4ac, when I evaluate that, it's 49. 49 is a perfect square. And once I see a perfect square under the radical, I punch myself. Because I think, oh, that's so silly. Why would I use the quadratic formula? Once I see a perfect square, you know what that means? It means it was factorable. So 1 plus 7 over 2 and 1 minus 7 over 2. So 1 plus 7 is 8. 8 over 2 is, of course, 4. Or 1 minus 7 is negative 6. Negative 6 over 2 is negative 3. Well, that was silly. Why would I use a quadratic formula? So I'll do a side by side. Okay, so once you're at that step, always ask yourself, is it factorable? Because if it is, why go through all that trouble of using this giant formula, right? You don't need it. You don't need it if it's factorable. Just resort to just use your factoring techniques. Now, saying that, some students, they really struggle with factoring, so they just use a quadratic formula for every single question on the test. But if the question states you have to solve by factoring, then you gotta use your factoring techniques. Okay. Now, I guess you could cheat a little. You can just use the quadratic formula on a scrap piece of paper and then reverse engineer the factors, but that's time consuming. Okay, so let's just be practical and just improve your factoring techniques, because you'll need that skill in grade 11 and 12 anyways. Okay, so this is really good. Okay, so we got some examples where you do need the quadratic formula, like 2a. And then there's some, be careful, because you can use the quadratic formula and you end up with roots which are not real. The roots are not real numbers. So these are actually called complex numbers, okay? We won't encounter and work with them very often, but just understand, if you do get roots which are complex, they are beautiful numbers, okay? They are called complex numbers. It's just that we unfortunately don't work with them in high school math. Now in C, I'm trying to say, I did this example because if I really want to highlight if it is factorable, why are we using the quadratic formula, right? All right, so just go over example 2. That was really good combination of things. All right, last one. You have this equation, represents how high above the ground it is after t seconds. How long does it take for the ball to reach the ground? So let h equal 0. So negative 5t squared plus 7t plus 3. Is this factorable? I'm playing with the factors in my head. No. So if that's the case, use a quadratic formula. Now this time I'm actually going to round it to 2 decimal places. Okay? So you punch this with a plus and then all over negative 10, and then with a minus and then negative 10. So this is how I would do it. So negative 7 plus, be careful, square root all of that. And then divide by negative 10. So you get negative 0.34. Let's do 2 decimal places. And then let's do negative 7 minus the square root of 7 squared minus 4, negative 5, 3, close the bracket, So square all that and divide by negative 10. And it's about 1.74 seconds. Okay, let me just triple check that real quick. Beautiful. All right. So how long does it take the ball to reach the ground? So this answer makes no sense. How can it hit the ground? How can it hit the ground before we even threw the ball? So we reject it because t is greater than or equal to 0. Okay, this makes no sense. How can I say it hit the ball before I threw it? That's some magic. So therefore, the ball hit the ground approximately after approximately 1.74 seconds. Okay, on the test we'll tell you whether we want exact roots or we want approximate roots. Okay, and we'll tell you, of course, round it to 2 decimal places or whatever. Anyways, there we go. So now you have the ability to solve all the quadratic equations you want. If it's not factorable, use a quadratic formula. Forget the quadratic formula, no problem. Complete the square.